Today, we are going to look at something that might seem pretty simple on the surface, but is actually incredibly complex, and that's unloading LNG from a ship. I mean, you might just picture hooking up a couple of hoses and calling it a day, but as we will find out, there's so much more to it.
Oh, absolutely. You are talking about a substance that has had to be cooled down to negative 260 degrees Fahrenheit to even become a liquid.
Yeah, that's like negative 162 Celsius, right?
Right. So you can imagine that moving something that's that cold and energy dense takes a lot of careful planning and safety precautions.
It's not your average backyard barbecue fuel, that's for sure.
No, not at all.
All right, well, to help us navigate this complex world, we're lucky enough to have our hands on an actual cargo operating manual. Like, we are getting the inside scoop from a seasoned chief engineer.
Exactly. We are talking about a step-by-step playbook.
Yep. So our mission is to extract the most important ideas and essential facts about discharging LNG. We want to give you a clear understanding of the key stages and their significance without getting bogged down in the weeds, you know?
Yeah.
Okay, so let's dive in. First things first. Can any LNG vessel just pull up to any terminal and start pumping out its cargo?
Not quite. The first thing you need is compatibility between the ship and the shore.
Yeah.
Like, think about plugging in an appliance. If the plug doesn't fit into the outlet, it's not going to work.
Right. It's not a one-size-fits-all situation.
Right. And it's not just the physical connections either.
Yeah, I was going to say, I bet it's more than just making sure the hoses fit.
Oh, yeah, definitely. The crews on both the ship and at the terminal, they both need a deep understanding of how each other's equipment works and super clear roles and responsibilities. It's a team effort, starting from the second the ship even approaches the port.
So it's a lot of coordinating even before they get close to the dock.
Oh, absolutely. And every LNG terminal has its own specific set of procedures. There are protocols for everything, like the vessel approaching the dock, how it's moored, the way they connect those loading arms, actually transferring the LNG, disconnecting, and then even the ship leaving.
Yeah.
All of that is unique to that terminal. They have to follow those procedures down to the letter.
So no room for winging it.
Nope. Strict adherence to the protocol is absolutely crucial for safety.
So how do they make sure everyone's on the same page?
That's where these pre-discharge meetings come in. Representatives from the ship meet with the terminal staff. They go through the whole planned schedule, make sure they've double-checked all the safety measures. It's basically a big sync-up.
Yeah. And speaking of safety, the manual really stresses these joint safety checklists.
Oh, yeah, for sure. It's not optional. Both sides, ship personnel and terminal staff, they walk through the checklist together. They're confirming every single critical safety procedure has been acknowledged and agreed upon. It's a shared commitment to doing things the right way and keeping everyone safe.
So even before the ship docks, a ton of information is already being exchanged.
Yeah, a lot goes into it. The terminal, for example, they'll tell the ship exactly how the unloading arms are configured. That way the ship's crew can prep their onboard systems. And then once the pilot and the loading master have gotten the ship safely moored, they'll radio back to the terminal to let them know. It's constant communication keeping everyone informed.
So the ship is tied up. Everyone's talked, initial safety checks are done. What's next? How do they actually get ready to unload the LNG?
Well, the first thing is the chief officer.
Right.
They have to develop a detailed plan for the whole discharge and ballasting process.
Ballasting.
Yeah, because as they unload all that LNG, which is super heavy, by the way, they have to pump in seawater to compensate for the weight change. Otherwise, the ship could become unstable. So the chief officer has to figure out how much LNG goes out, how much ballast water comes in, and how to do it all while keeping the ship perfectly balanced.
So it's like a giant balancing act on top of everything else.
Pretty much.
Yeah.
And of course, just like before arrival, there's a whole set of pre-discharge checklists they have to go through as well.
So it sounds like they are checking and double checking everything every step of the way.
Yeah.
I guess when you are dealing with something as potentially dangerous as LNG, you can never be too careful.
Exactly. They have to be super meticulous.
Okay, so we are back to this pre-discharge meeting. And they're going over the ship shore safety list again, right?
Yep. And they both sign off on it. It's that ongoing process of checking and agreeing, making sure everything is as it should be. And then you have what's called custody transfer measurement. Basically, they have to figure out exactly how much LNG is on board before they start pumping it out. It's like taking inventory.
Oh, so they have to agree on the exact amount of LNG before anything is transferred.
Right. And this involves people from the terminal, independent surveyors, and sometimes even government officials. It gets pretty official because this measurement determines how much they get paid or how much they pay. And then, of course, there's the actual physical connection between the ship and the shore.
Right. So what's involved in actually connecting the ship to the terminal?
Well, all the equipment at the manifold,
Manifold, sorry to interrupt, but what is a manifold?
No, the manifold is basically the spot on the ship where all the pipes connect to the shore. It's like the main interface. And they have to make sure all the equipment there is set up correctly. This includes things like the bonding wire, which prevents static electricity from building up, telephone lines for direct communication, and of course the loading and bunkering arms.
And the terminal gives them a manual with all the specifics, right?
Yep. They have very specific instructions on how everything should be connected. There's no room for error there.
It sounds pretty intense. And on the ship, who's in charge of making sure all this is happening correctly?
That would be the chief officer. They supervise every single aspect of the unloading operation. They're the ones who make sure everyone on the ship is doing their job and that everything is happening according to plan.
I can only imagine that's a lot of responsibility. And speaking of keeping an eye on things, it seems like they're constantly monitoring the cargo tanks as well.
Oh yeah, throughout the entire discharge process, they are checking the liquid levels in the tanks, the temperatures, the pressure, all that. They record everything in something called a cargo monitoring record. This helps them keep track of how the discharge is progressing and spot any potential problems early on.
So it's like a constant health check on the whole operation.
Yeah, exactly.
And they make sure the vessel is prepped to cool down the unloading arms on shore.
Right. Because remember, the LNG is extremely cold, so they can't just pump it through warm pipes. They have to cool everything down gradually to prevent damage.
That makes sense. And I imagine there's one final safety check before things really get going.
You got it. The crew and the terminal staff do one last inspection together, just to be absolutely sure that everything on both sides is ready to go and it's safe to proceed. They don't take any chances.
So the ship is hooked up, everything's checked, but before they can start pumping out the LNG, they need to cool down the lines first.
Right. You're essentially about to introduce a liquid that's hundreds of degrees below, freezing into pipelines that are at normal temperature. If you did that without cooling them down, the metal could crack or even shatter.
Wow. So it's not just about the LNG staying cold, it's about protecting the equipment itself.
Exactly. And that sudden temperature change is called thermal shock. That's what they are trying to avoid by doing this gradual cool down process. They want to slowly bring the temperature of the entire system down to a safe level.
Okay, so how do they actually go about cooling the lines?
So they use a spray pump that's located in Newell 4 cargo tank, and they circulate a small amount of the LNG through a system called the spray header and then into the main liquid manifold pipework. And the manual also says they can use the fuel pump in number 4 tank if they need to supply boil-off gas as fuel for the ship's power plant during this process.
So they are using a little bit of the LNG to cool the lines for the rest of the LNG.
Right. And as that super cold LNG flows through, it pushes out any warmer vapor that's already in the pipes. That vapor doesn't just get vented out, though.
It doesn't.
No, they capture it. It goes through these crossover pipes, then through the liquid header, and ultimately ends up back in number 4 tank through the filling line. They're not wasting anything.
That's a relief. I was about to ask about that. So it's all a closed loop.
Yep.
And how do they keep the pressure stable in the cargo tanks during all this?
They use the LD compressor and a vaporizer.
Okay.
This combo provides fuel gas to the ship's power plant, which helps maintain the right pressure in the tanks as they are cooling down.
Got it. So this is all happening according to a very specific sequence of valve operations, I imagine.
You bet. The manual tells them exactly which valves to open for the spray header, the liquid header, and the port manifold. The vapor dome outlet valves, which connect to the vapor header, are usually left open too. And there's an automatic gas control system that helps regulate the whole thing.
So some of this is automated.
Oh, yeah. They set the LD compressor pressure control valve to a specific pressure, which in this case is about 6.0 kilopascals. That ensures that the right amount of vapor is being used as fuel. So basically, the LNG starts in the spray header, goes to the manifold, through the crossover valves, into the liquid header, and finally back to number 4 tank through the loading line. It's quite a journey. Yeah,
like a carefully choreographed dance for super cold liquid.
Right.
And all this is being controlled from the IAS, right? The Integrated Automation System.
That's right. The IAS is like the central command for the ship. And once the spray pump is on, they'll open and close the loading valves on each cargo tank one by one. This makes sure the entire liquid header, which is the main pipeline for the discharge, gets cooled down evenly.
Okay, so what are they watching for during this cool down process? How do they know everything is going as planned?
They are looking at a bunch of different things, like the levels in the cargo tanks, the pressure and temperature at the liquid crossover, the temperature of the whole liquid header, and the pressure in the vapor header. If anything looks out of whack, they know there might be a problem.
And what's the magic number for the temperature? How do they know they're good to go?
The liquid header has to reach a negative 100 degrees Celsius, and they'll also see frost forming on the outside of the loading valves. That tells them they've hit the right temperature.
Okay, so when they hit that temperature, what happens next?
They turn off the spray pump from the IAS, but if there's a long wait before the ship actually docks, they might need to restart the spray pump every now and then to keep the lines cold.
I see. So they just want to maintain that temperature.
Right. And they have to be mindful of this little quirk. When that super cold LNG flows back into null 4 tank, it can actually cause the temperature at the very bottom of the tank to rise a bit. So they have to wait for the temperature to settle down before they take any important measurements.
That's interesting. So even though they are adding something cold, it can cause a temporary temperature increase somewhere else.
Yeah. It's a bit counterintuitive, but it's just because of the way the system is designed.
Okay, so now we've got the ship's internal lines all cooled down. What about the unloading arms on shore? I'm guessing those need to be just as cold, right?
Absolutely. They can't just connect a freezing cold pipe to a warm one. So once they connect the arms to the ship's manifold, the first thing they do is pressurize them with nitrogen and then purge them until there's almost no oxygen left inside.
Ah, so they are making an inert atmosphere in the arms, like flushing out the air with nitrogen.
Exactly. And the nitrogen comes from the shore facility at a pressure of up to 300 kilopascals according to the manual. It's a safety measure to prevent any potential explosions or fires.
That makes a lot of sense. And I bet they do a leak check after that too, right?
Oh yeah, of course. They go over all the connections, the flanges, everything. Usually they use a soap and water solution to check for bubbles. If there's any sign of a leak, they have to fix it before they can move on.
So once they're sure there are no leaks, then they start cooling the arms down.
Right. And that procedure is done in close cooperation with the terminal. They use either a spray pump or a main cargo pump to circulate the cold LNG through the arms. And the ship's crew always follows the terminal's specific cargo operation manual. So they're always on the same page.
Sounds like there's a lot of communication back and forth between the ship and the terminal.
Oh, definitely. There are a lot of moving parts, so they need to be in constant communication. And there are a few things they have to do before they even start cooling the arms down.
What kind of things?
Well, first, they got to finalize the ship shore safety checks. Then they might have to shut down any BOG burning operations on the ship, depending on the terminal's rules. They're also going to finish up the custody transfer measurements, which is where they agree on the exact amount of LNG being transferred. And finally, the vapor line between the ship and the shore has to be open and ready to go. So a lot of boxes to check before they can even start.
All right, so once all those boxes are checked, how do they cool the arms using a spray pump?
So they'll use an O4 spray pump again, and they'll set it up to circulate the LNG. Then they'll get the port manifold ready by opening the cool down in ESD, which stands for emergency shutdown, liquid manifold valves.
Okay.
Then they'll start the pump and adjust a return valve to build up pressure in the system. And as they do this, they'll be watching the arms for frost, which tells them the cool down is working. They're aiming for a temperature of about negative 130 degrees Celsius, and the manual says this can take up to 80 minutes or so, but it can vary.
Okay, so it's a slow and steady process. And once the arms are cold enough,
then they open the double shut valves on the ship's manifold and close the cool down valves. They stop the spray pump and open the return valve to drain any leftover LNG back into the tank.
And what about the other way of cooling the arms? The one that uses a main cargo pump, how is that different?
It's similar in principle, but instead of using the spray pump, they use a main cargo pump, like the one in number 2 tank, to circulate the LNG within its own tank. They open specific valves to create a loop that goes through the port manifold and the shoreside arms, cooling them down.
I see. So either way, they get the job done.
Right. And after the cool down, no matter which method they use, the terminal will always require them to do a cold ESD test.
A cold ESD test? What's that?
It's basically making sure the emergency shutdown system works properly at these super low temperatures. They can't start unloading until they know that safety system is 100% functional.
Right, because if something goes wrong, they need to be able to shut everything down immediately.
Exactly.
Okay, so the arms are cold, the emergency shutdown system has been tested, now we can finally start unloading the LNG.
Right. And remember, we're not just unloading it, we're also returning vapor from the shore. So once the cool down and ESD tests are done, or sometimes after they start the cargo pumps, there's a whole bunch of valves they need to open.
Okay, hit me with the valve list.
All right, so we've got the double shut valves on the port manifold, the manifold liquid ESD valves, the main vapor ESD valve, the vapor return crossover valve, and the vapor dome outlet valves on all the cargo tanks.
That's a lot of valves. And are all of these operated manually?
Not all of them. The liquid branch valves for each cargo tank and the filling valves are automated. So when they start a cargo pump, the branch valve automatically opens and the filling valve automatically closes.
So the system is designed to direct the flow where it needs to go depending on which pump they're using.
Exactly. It takes a lot of the guesswork out of it.
Makes sense. So is there a certain order they usually unload the tanks in?
They usually start with number 1, then go to number 2, number 3, and finally number 4. But the chief officer can change that order if they need to based on the overall plan.
Gotcha. So it's not set in stone.
Yeah.
So let's talk about starting the first cargo pump. What happens there?
So for the first pump, let's say in number 1 tank, the system will automatically close the branch valve, isolating that tank. Then it will open the discharge valve about 20% and then start the pump. But at first, the LNG is actually just recirculated back into the same tank.
So it's not going ashore right away?
Not right away. This is just to get the pump going and build the pressure, and then they'll do the same thing for the second pump in the same tank.
So both pumps are running, recirculating the LNG.
Right. And then they gradually open the branch valve while simultaneously closing the filling valve.
So the flow gradually shifts from recirculating within the tank to heading out to shore.
Exactly. And they start the other cargo pumps as needed based on what the terminal tells them about flow rate and pressure.
Makes sense. And this is where the vapor return from shore comes in, right?
Yes. Once they have a steady flow of LNG going to shore, they'll ask the terminal to start sending back vapor. As they pump out the LNG, the pressure in the tanks would drop, so they need to replace that pressure with vapor to keep things stable.
And the vapor is basically just LNG that has warmed up and turned back into a gas, right?
Exactly. It's all part of the cycle. And while all this is happening, they have to be super careful and keep a close eye on the pump motors. The manual really emphasizes monitoring those ammeters to make sure the current is stable. If it's too high, it could mean there's a blockage somewhere.
So it's like watching the gauges on a car's dashboard to make sure everything is running smoothly.
Exactly. And if a pump shuts down for any reason, they have a specific procedure to restart it, and they have to do it within a certain time limit to avoid damaging the pump.
And as they get towards the end of the unloading process, what happens then?
As the level in the tanks gets lower, the pumps have to work harder to keep the LNG flowing. So they gradually close the discharge valves a bit, which is called throttling, to maintain the right pressure difference. And they start doing this when the level in a tank hits the 2-meter mark. If they see any fluctuations in the ammeter readings or the discharge pressure, then reduce the flow even more until everything stabilizes.
So they are fine-tuning the flow as the tanks empty out.
Right. And there's a minimum flow rate they have to maintain, which is about 658 cubic meters per hour. Below that, they risk causing damage to the pumps.
I see. So it's a delicate balance between keeping the flow going and not pushing the pumps too hard.
Yeah, exactly. And once they've transferred all the LNG, they drain